This is my Capstone project. Called it Smart Home because I had to give it a name, and I'm very creative. Project advisor, Dr. Brad Alibi. Since the dawn of time, has used technology to make our lives easier. Whether it's a wheel for transportation or a cellular phone for communication. For instance, most cars have key fob or remote things that you use to lock or unlock to start your car. And do other things that take over for you. Instead of having to use an actual key, like in the 20th century, you just push buttons.
Back in the olden days.
Back in the olden days.
In the Stone Age.
So it's got me thinking, why don't we do the same thing for our homes? We could, of course, lock and unlock. We could control any of the lights electronically. Thermostat, television, channel surf, cell phone, whatever else you could think of, really. I mean, any function of the home operation can be controlled with the system. It's going to be a client server architecture, so there's going to be a central program listening, and then the client software would connect to that and issue commands. Either through a local area network or through the internet, control your home from anywhere in the world with internet access. Or you can use a mobile app and do all that, and it'll fit your pocket. And the other side of it is obviously you're going to need some special hardware to do this, to actually run the lights, give commands to the TV. For the door lock, I actually came up with this because it's what people are used to. And then I built this guy that actually this fits over the door and it actually turns my deadbolt back and forth. It's a little clunky, but it works.
Clunky? That thing is so cool.
That's what I said.
And the best part, it's magnetic. So it just fits right over the door.
That's even cooler.
So, and if you walk up to it from the inside, automatically opens. So, start. It uses a 66-bit rolling code. Every time you push the button here, it sends a different value. So someone listening with their own receiver can't just send the same code and get into your house. You can connect up to 15 transmitters. So say you've got a bunch of roommates, you don't have to get keys made, just sync with that. According to the paper that came with this, 66 bits allows for this big number of combinations. So at about 10 scans per second, it would take 230 billion years to brute force every combination. That's a long time. Then there's the Arduino microcontroller. And it's basically a tiny computer. That's this guy right here. On a little board. It's got a processor, it's got memory, it's got input and output. You can program it using the Arduino IDE. I left that part out. But it's basically just C++. You just write C++ and controls the computer, which can control other things. So what I've got here is the controller actually takes input from the receiver that this is synced to, and it sends that to the Arduino. It says, okay, that was the lock button, so I need to run the lock function, which controls the servo using a PWM output, a pulse width modulation, and does a little speaker tone, a different tone for lock and unlock. Let's see, so there's three parts to the whole thing, right? There's the client software, of course, it's what you're going to actually use to issue commands. There's the server software that runs in the background and listens, and then there's these remote devices that are going to actually control our lights and TV and whatever else we can think of. The client, like I said, it's just to allow the user to connect to the server. Fairly basic. You enter a username and password to log in, and I actually came up with an interesting protocol to send login credentials over an insecure channel. And ideally, we'd be using OpenSSL or something, but I didn't have time to implement that. But I'll get into that in just a minute. Right now, I've just got one written. It's C# from Microsoft Visual Studio. Simple to use. Just a click button, basically. It's got built-in administrative functions. You can add or remove users, change their password, and change their rights. Server was written about 1,200 lines of Java code, 7 different files, I think. It just opens a TCP socket and listens. Pretty basic. Yes. So client connects. It automatically runs it immediately runs the login routine, and if it's correct, it will move to accept commands from the client. And every time a command is sent, it checks that command against that user's privileges, and if it's authorized, it'll send a feedback saying, okay, lights off or whatever, and if not, send an error message. This is the connection protocol that I came up with. I don't know if anyone else has done this before, but I thought of it. Basically, the server just generates a random number, basically, a really big random number, 240-bit challenge vector. Compute the hash of that using SHA-1. It's a 160-bit digest, so very secure. Sends that to the client. The client receives that and tacks onto that, concatenates with the digest of the password, which is a one-way function. All this is one way, so there's no going back to that hash. The client sends that to the server, and the server basically computes the same thing on its end, and if both of the hashes match up at the end, the user is authenticated, they're logged in. If not, it's the wrong password. Remote devices, as you see, I have the one remote built for right now. We already went through how it works. I also have some lights that I'm going to demonstrate here in just a minute. Demonstration. I had all this open. Here's my server. It's all written in Java. All it does is sit here. It actually doesn't do any output. It's all stored to a log file that you can read from the client. So there's that. And now we open our client, which could be on any computer as long as it just has to connect to the computer that the server is running on. So we enter our login information here. I already have it saved. Login. Oh, and if just to show you, if I enter the wrong information, say I do 124 or something, access denied. So it's checked. Now login. So we do this, we should be able to. First, I got to power on for the transmitter. This is actually the same exact thing as this. I just basically wired it into the controller. So that's going to send a command over there and lock the door and unlock the door.
Wow, that is cool.
And this just does the same thing right now. But if you had a back door, you could hook another transmitter up to it and to your front or your back door. Lights, can turn the lights on, off. Sounds cool. On, off.
Now, are they on a dimmer too? Can you kind of
They
use
are,
the slide?
but the Arduino software that I wrote is buggy and it crashes out after you dim it for so far.
They don't.
It'll dim some and then it kind of crashes out. See, there it goes. It's actually working. There's the other one. So there's your mood light. And we have other functionality. It just doesn't do anything yet, but it's as simple as wiring into a universal remote, basically. Make that pretty. Thermostat. which I just thought was a good idea because I'm always sitting on the couch thinking it's too hot or it's too cold.
Get up off the couch.
That's pretty much the point, just keep me on the couch.
It's a lot of work that goes into being lazy.
This is our administrative fund.
There you go. It's the beer bringing it.
Don't make me laugh when I'm filming.
I can the rights, like here.
So how do we get the fridge to prepare our meals?
That's a different.
See,
So you just have to double click and it changes the rights?
Mhm.
That's pretty easy.
Yeah, it's actually it's changing. It's all going to a flat file right now. Got one little output I forgot to take out. Do this and that's not showing. So there's a bug there. I added the server log function. Yeah, we can just do this and let's see, say Lauren, I don't want her to be able to control my door. Okay? And since I forget her password, I'm going to change it to A. Password for Lauren. Okay, so now I'm Lauren. I'm going to log in. And I want to lock the door.
Oh, that thing's easy.
So that's pretty much how that works.
What it does if you want to stay on the couch.
Yeah.
Well, no, you can.
Or a long stick.
So I got my reaching stick.
Saw how I went, how I finished. Home automation at the touch of a button. Ironically, the march of progress will have us sitting down a lot more. So I'm going to just get up, turn off that light that we left on. Nightmare is over. Some challenges that I faced along the way was specifically the RxTX library used for interfacing this guy, the actual controller, with the server, the Java software, so they could send commands. It was a pain to install and use. It got figured out, but it was difficult. To get the DLL files just right. Fortunately, the Arduino IDE is open source and has a built-in serial monitor. So when you're writing these programs, you can check your input and output over the serial right in the IDE. So I looked at that code and reverse engineered it a little bit and got it to work mostly. Pushing the button on the transmitter. What I had to do is simulate this with that. See, these run off of 12 volts, and these the Arduino runs off 5 volts, which is not enough to activate a button on here. So I had to use an H-bridge, which is just a fancy circuit that steps up a 5-volt input to really almost any voltage up to, I think this one will have up to 50 volts. But all it does is it takes 12 volts and uses 5 volts to switch it. So using the Arduino's 5 volts, I can switch 12 volts to either of the button inputs, thereby pushing the button. Lessons learned, I learned a lot about how these key fobs actually work and why they're so secure, and of course why they're so popular. I learned how to interface the Arduino with the computer using this RxTX Java library, which now I can do so many other things I can do. And probably the most important thing I learned is that landlords get really nervous when they see black boxes with red lights and text. test your door. Everybody thinks it's a bomb. When they see it in my house, is that a bomb?
You're gonna blow out your own door.
Why are people thinking I'm rigging my door to explode?
That is the next step.
Yep.
Insurance purposes.
Unauthorized. Boom.
The great thing about this is that everybody has ideas. So, they can add to it or improve it.
Like that.
Everybody has something.
Like the shotgun over your
That's
door.
great because people are really interested in it. Some things I'd like to do is integrating two-way communication using XP. And all that is a wireless communication module that allows these microcontrollers to talk to each other wirelessly. Right now, it's just one-way communication. I give it a command, it does it. But I don't know that it's actually received it and it says done it. And so it doesn't get feedback to the server to say, yes, the door is locked or yet unlocked. But it's really complicated and I couldn't get it working in time. I'd like to rewrite the server to use a database. Right now, all the user information is stored in a text file. Works, but it's funky and ugly. I want to do the other devices, of course. I really want to get that thermostat thing working. What else? Of course, I need an app for this to be really useful so that I can just pull my phone out.
Well, you know what? Jason Eads is working on iPhone apps for his Capstone, so maybe the two of you can collaborate.
We should work together.
You can find Android users as well.
Yeah, I would, but I don't know anybody who uses Android.
Well,
We all use
Parker.
iPhones.
Parker's daring to be different.
I will put my.
Yeah, I have a broken $1 phone.
Let's go. A timer on the server to say, turn off the TV in 30 minutes, so you can fall asleep with the TV on, but not leave it on all night. Or you can say every 7 a.m. Monday through Friday, I want my lights turned on and the coffee pot on.
oh, I like that coffee pot idea.
Yeah.
Have a Friday.
So that's pretty much it. I want to thank Dr. my project advisor, the whole computer science department, especially Mr. King for not being here. That was really helpful.
Need all the harassment left for you.
Right. He's my department advisor, and he's been a lot of help for me, and he's just generally a hoot. Everybody else who's helped out and basically just put up with me. And thanks to the ACM for allowing me to do this demonstration. He must